Hi, I'm Darcy Lucier, and welcome to this webcast on Demystifying the Cloud. My hope is after watching this presentation, you'll have a better understanding of what the term cloud and cloud computing really means. The idea of cloud has been with us for quite a while. For many years, a cloud was used in architecture diagrams to represent the internet, a vast web of interconnected computers that transported data around the world. Then in the mid to late 2000s, we started to see this term cloud take a different shape. Companies began to emerge that either had cloud offerings or were pure cloud companies. And while these early cloud companies talked up their offerings, they didn't do a great job explaining how cloud was different from seemingly similar services. For instance, if I could host my website with a traditional hosting provider, how is that any different from hosting my website on a cloud provider? People were confused, but curious about this new term cloud at the same time. And then something horrible happened. Marketing departments got a hold of the term cloud and opened wide the floodgates of misinformation. Consider this ad from Microsoft, which associates terms like create, connect, and share with cloud. And while you could definitely connect dots from cloud computing to cloud services to cloud-enabled applications that provide ways to create, connect, and share, the message given was oversimplified and caused even more confusion. And if the consumer space was being fed confusing messages, so too were executives who were hearing the cloud buzzword from vendors, consultants, and even their own people. Was the cloud a data center? Was it virtualization? If software as a service was being used, does that make an organization cloud enabled? There was a lot of confusion to go around at every level, whether it be consumer all the way up to executives. Okay, so let's forget all of that and re-baseline our definition of what cloud computing is. Eric Knorr from InfoWorld wrote this quote in an article a number of years ago, but it holds true today. He said, "Cloud computing comes into focus only when you think about what IT always needs, a way to increase capacity or add capabilities on the fly without investing in new infrastructure, training new personnel, or licensing new software." Cloud computing offers the same services as traditional hosting models, the ability to increase capacity and add capabilities. But where cloud computing is different is in the rest of that quote, on the fly, without investing in new infrastructure, or training new personnel, or licensing new software. So let's look at how cloud services have evolved with this new definition in mind. Let's consider the infrastructure problem that cloud addresses. Well, here we have a physical server, as we'd find in almost all companies. If we go really far back and you want to add extra resources, you'd add on more physical servers. But then virtualization came along, and we were able to add multiple servers into our networks with the only limits really being the hardware of the physical servers that they ran on. But what if we wanted to increase the power or scale of our infrastructure? Well, one option is to scale up. In this scenario, a physical server is updated with hardware that adds to the processing, storage, and memory limits of the physical box. But there's a problem with this model. You sink costs and you create waste. The parts you install will eventually be replaced or outlive their usefulness. And over time, the investment you put into a single physical server could be well over what you initially paid for the physical machine in the first place. In addition, there's management and maintenance that's required. Another option we have is to scale out. Now in this scenario, we add multiple physical machines to spread the processing requirements over a larger area. Now the issue here though is that adding physical machines, which in turn run multiple virtual machines, increases the IT management footprint and costs. In either scaling up or scaling out, there's other considerations like the cost of running physical hardware, the building they're housed in, the electricity required to power them, the labor required to maintain them, the software licenses required to be installed on them. Running your own infrastructure can be costly on many factors. In fact, if we consider what goes into just one physical server that's running maybe a few virtual machines, well, we can easily get to a number around $10,000 to $20,000. and that's just for a single server. And that's not factoring in labor or any other overhead costs required to operate that server. Everything we just discussed is what Microsoft was facing when the idea of Azure was formed. Now, Microsoft had numerous data centers to support their products like Hotmail and MSN, and they found that the hardware management was just too cumbersome. Physical assets couldn't be repatriated to other data centers easily, and there was no easy way to quickly add computing power. Microsoft solved their own internal problem by implementing a cloud, and then decided to take it to the market so other companies could gain the benefits that they did. This brings us to the first cloud service model, infrastructure as a service. It's the idea that instead of setting up your own physical or virtual infrastructure locally, you do it leveraging a cloud provider's infrastructure instead. This can include virtual machines, entire virtual networks, core computing instances, and native service offerings. Now, it should be pointed out that there are different cloud models that can be implemented. There's public cloud, where all your resources are located with a cloud provider. There's a private cloud, and this is where you set up your own cloud infrastructure on top of your own hardware. And then there's also hybrid cloud, where you leverage certain aspects of a public cloud infrastructure in concert with your own local infrastructure. Now, while private and hybrid allows you to take advantage of increasing capacity and adding capabilities on the fly, there's still operational and capital costs involved, since the organization is the one running all or part of its infrastructure locally. Cloud isn't just about infrastructure, though. The cloud can enable application developers by offering packaged services that reduce the amount of development time required to take a product to market or a project to completion. By abstracting away areas such as hosting configuration, notification services, and data storage, application developers can focus more on the business logic they need to implement rather than configuring the operational environment their applications need to run. Now, this is what's known as platform as a service. Platform as a service is when you leverage packaged cloud services to facilitate usage scenarios that would otherwise require you to build components or manage resources yourself. Platform as a service is a cloud model that leverages infrastructure as a service, but further abstracts away the lower level administration. For the last cloud model, we look at applications offered in the cloud. Two examples are Salesforce, which offers a suite of sales management tools, and Office 365, which provides internet access to productivity applications. The value proposition from these companies is that the overall investment by an organization is greatly reduced because traditional activities are abstracted away. Let's take a look and see what the difference is between installing Microsoft Office, for instance, on-premise compared to leveraging it in the cloud. So to do a Microsoft Office implementation on-premise, well, you may need to procure infrastructure, depending on whether or not maybe you're installing SharePoint as part of that suite as well. Well, SharePoint's a server-based product. You may need to procure infrastructure, you may not. You also need to install the software and deploy the software. Now, let me clarify the difference there. Let's say you have an enterprise organization and all the desktops leverage the same default image for all employees. Well, you still have to install the actual software onto an image, and then you need to now deploy that new image to all of your desktops across your organization. You also need to consider updating and patching the software, so as security updates come out or feature updates come out, all of your deployment needs to be updated. You may need to hire for required service levels, so you implement a new application in your organization, your tier 1 help desk support needs to be able to manage this new wave of calls that will be coming into help desk or tickets that will be opened in your ticketing system. And there's training that needs to be considered as well. Employee training, the ones that are going to be end users of the application, and as well as the service people who need to have training on how to support this application in your environment. Also potentially IT people who need to understand what needs to happen on servers, and also from even just a desktop deployment point of view. Compare that now to cloud. If you were to run Microsoft Office 365 in the cloud, well, you need to train your staff, and that could still be your support level staff as well as your employees. But you're not the ones procuring infrastructure. You're not the ones installing the software, because Office 365 is is accessed over the internet. You don't need to deploy the software because Office 365 is available over the internet. Any updates or patches happen automatically behind the scenes by the vendor. So there's a lot of value in looking at a cloud-based application model as opposed to purchasing it, installing and maintaining it yourself on your own hardware. So this cloud model is called software as a service. And from Wikipedia, it's defined as a software licensing and delivery model in which software is licensed on a subscription basis and is centrally hosted. It is sometimes referred to as on-demand software. SAAS is typically accessed by users using a thin client via a web browser. So if we now go back to our models diagram, we can see that software as a service sits side by side with platform as a service, ultimately on top of infrastructure as a service. Now, one thing to note with software as a service, there's a lot of applications and a lot of software available over the internet. But just because it's available over the internet doesn't mean that it's necessarily a cloud solution. Remember, if we go back to our original definition, we define cloud as, yes, being able to add capabilities and capacity, but on the fly. So as an example, if you have an internet-based application provider and you want to add 10 more users, if it takes a day or 2 days for that vendor to add those users and grant them access, I would argue that that may not meet our definition of what a cloud service really is. If you're able to go on and through self-administration add those 10 users and have them immediately get access to the application, that I would consider being closer to an actual cloud service. So remember our definition. Go back to that, and whenever you're evaluating a software as a service, compare it to those criteria. If they match up, consider them cloud. If they don't match up, well then really all you're doing is paying for software that happens to be hosted elsewhere. I want to take some time now to bring up a few discussion points when considering a cloud solution, be it infrastructure as a service, platform as a service, or software as a service. The first is this idea of accessibility. Now, the cloud has been thought of as data everywhere, but that's not really the case. Now, consider this map of Microsoft Azure data centers. There are most definitely physical locations where data is stored, and in various geographies that carry with them their own nuances. If you think about North America alone, the West Coast subject to earthquakes, while the East Coast subject to hurricanes and storms. Even locations as far as, are you going to store your data in a different continent? What's the consequences of that? Are you going to see any speed issues or accessibility issues from doing that? Considerations like data and system backups, ensuring always-on accessibility, application speed, these all need to be addressed in any cloud architecture. Just putting it up into the cloud and not thinking about these things, that's a recipe for disaster. You still want to be thinking about how are we going to ensure that our data is accessible and that our applications will continue to have whatever level of uptime is required. Another consideration when considering a cloud provider is what development platforms are supported. For some of the larger ones, like Amazon Web Services and Microsoft Azure, usually you're okay, and there's various ways that you can do your cloud deployment that will support whatever your development tools and technology stack is. But there are some out there that are very specific. For example, VMware's Cloud Foundry is entirely based on Java, Ruby, and Node.js. So it would not be an option in a Microsoft setting. So doing research on available cloud providers is definitely required because they aren't all the same, and they all will have some different nuances and maybe even different focuses. Some may be more focused on the infrastructure as a service, where others will be purely platform as a service. Some, of course, will also just be solely software as a service, and some will be a combination of all three. And of course, we have to touch on security and privacy. Security and privacy in the cloud is a huge topic and will justify its own presentation, just to cover a lot of bases. But one thing that I like to raise with people, there's this notion that the cloud is not as safe or secure as an organization's own infrastructure. And what I like to do is challenge people on that and say, well, we're talking about data centers whose entire role, entire purpose is to store data, host applications, host services. And if any aspect of that business falters, the entire business falters. They must be secure and they must enforce privacy. Now, if that's their lone focus compared to a business that happens to have an IT department that needs to support the main role of business, can we actually say that our internal infrastructure really is that much better than going to a cloud provider? Let me talk a little bit more about what I mean here. So think about your own organization for a second. How secure is your data center? Do you even know where your data is located or where it's stored? Do you know whether or not people have access to it, whether that be physical access or virtual access, and how it can be accessed? Are there security audits that are performed, not just on maybe your data center, your IT department, but on your organization as a whole? Are you aware of where there may be security vulnerabilities, where hackers or attackers could get in and access data or cause damage to your infrastructure? Who has access to your physical data center? What is the disaster recovery plan? If something horrible would happen, and not necessarily a mass scale of like an earthquake or a hurricane, but even something as simple as a fire or a power outage. What happens if there's a power outage? What's your disaster recovery plan for your organization to ensure that you're not going to lose business or productivity in those cases? Now, with a cloud provider, these things are thought through. How secure is your data center? A good cloud provider should be able to tell you that. How often do you perform security audits? A good cloud provider should be able to tell you that. Who has access to your physical data? What's a disaster recovery plan? These are all questions that should be able to be answered, not only by a cloud provider, but again, I challenge your own organization as well. And what you may find is that it is actually more secure going with a cloud provider. And it may also raise some questions that you need to address in your own organization about security. I like to use the metaphor of storing money. So if you had $1 million, where would you put it? Would you store it in your mattress at home, or would you store it in a bank? The bank's main job is to keep your money safe. Big vaults to keep robbers out, numerous safety systems in place to deal with disasters, security personnel to guard your money, and bank employees whose sole job is to keep your money safe. Your house's main job is to not keep your money safe. It's to provide a safe dwelling for you. Yes, you can still keep your money at home, but your house is not designed to solely protect your money. Maybe you have a safe in your basement, but I would guess the safe isn't to the same standard as a bank's. And while you may have alarm systems for intruders and fire, how effective are those in ensuring your money is safe in your own house? Now, obviously, organizations may feel a little sensitive about this, especially ones that have invested a lot in their own IT departments. But the reality of cloud is that it doesn't take IT away. It just changes what their job role is. It changes their approach to how they maintain infrastructure and systems for a business or an organization to operate. Okay, so let's wrap up here. So let's go back to our definition of what is cloud computing. Well, cloud computing comes into focus only when you think about what IT always needs: a way to increase capacity or add capabilities on the fly without investing in new infrastructure, training new personnel, or licensing new software. And we also talked about the 3 cloud service models. So infrastructure as a service, platform as a service, and software as a service. So remember, platform as a service is when you leverage packaged cloud services to facilitate usage scenarios that would otherwise require you to build components or manage resources yourself. And software as a service was software licensed on a subscription basis that is centrally hosted and typically accessed through a thin client, like a browser. Thank you very much for watching this webcast. I hope I was able to demystify the cloud for you at some level. And if you have any questions or comments, you can contact me either through Twitter or through my blog as well. And I encourage you to continue to look into cloud and cloud computing.